there's an idea in my head right now that I want to share with you. And so I'm moving my mouth and making these sounds, and somehow you can take these sounds, which are just vibrations in the air, and understand the meanings and ideas that I'm trying to convey. You are all mind readers. And language is our uniquely human superpower. I am a computational cognitive scientist, and the question that I ask in my research is, how does language work in the human mind? Even though language is so fundamental to our daily lives and to the human experience, we as scientists know surprisingly little about it. And part of that is because it's just really hard to study how language works. I mean, think about it. We can't do a truly controlled experiment because we would need to isolate humans from outside language influences from birth. We can make progress through controlled experiments in laboratory settings, but these can't get at the full richness of how we use and learn language in the real world. Now, what a lot of other sciences do in this situation is turn to animal models. But unfortunately, I hate to break it to you, but animals aren't writing sonnets or learning French anytime soon. So we're limited in our human experiments, and we can't do animal experiments. But in recent years, there's been a new alternative for us to experiment with: artificial intelligence, or AI. So instead of in vivo experimentation, which uses live model organisms, in my research, we do experiments in silico, meaning in computers. So what does it even mean to study how language works? Well, let me put the question another way. What does it mean for you to know a language, like English? You might be thinking about things like the grammar rules that you were taught in grade school, like never end a sentence with a preposition, for example. But despite what your teacher said, these are just rules that people made up. You can break these rules and still be speaking English. I mean, we do it all the time. So then what does it mean to know a language? For me, knowing a language means having a grasp of the underlying rules and structures that allow us to be able to create and understand an infinite number of sentences in that language, including sentences that we've never heard before. Take this example sentence. The green walrus sneezed the foam off my matcha latte. You've probably never heard this exact set of words before, right? But right away, two amazing things happen. First, you know that it's a well-formed English sentence, so the subject, the verb, and the object are all in the right place. But second, you have a vivid sense of what it means. How can you understand a sentence that you've never heard before in your life, that maybe no human has ever even written down before? Well, you know what the individual words mean, like green and walrus, and you know how to combine the meanings of words into the meanings of phrases. So you know what a green walrus is, even if you've never seen that phrase before. And you know how to combine the meanings of phrases into the meaning of a sentence. So you know what it would mean for a green walrus to sneeze foam off of a matcha latte, even if you've never seen that sentence before. Now contrast that with the same exact sentence, but reversed. Latte matcha, maya foam, the sneezed walrus green the. Again, if you're like most people, you've probably never heard this exact combination of words before. But here you know right away that it's not a proper English sentence, and more importantly, you can't make meaning out of it, because you can't apply the rules and the structures of English here. Now, you might not be thinking about these structures consciously every time you interpret a sentence, but under the surface, language is a system of structures and rules that allow us to combine meanings and concepts and thoughts together in a very systematic way. Now, this might seem kind of technical, but if you think about it, it's incredible. This is our superpower, because these structures are what allow us to create and understand an infinity of sentences, even though our brains have a finite set of resources. And what's even more amazing is that even though all languages around the world seem different on the surface, they can often be described by the same underlying structures. That's actually how I got fascinated by language in the first place. So growing up, I was exposed to multiple different languages, and the more languages I encountered, the more curious I became about what all languages must have in common under the surface. And after years of studying math and computer science at Harvard, it finally clicked for me that I should bring the tools and precision of mathematics to study the messiness of the inner workings of the human mind. And that's how I stumbled across the field of computational cognitive science. Now, I'm not just interested in describing what the structures of language look like. My ultimate goal is to establish a mathematical account for how they work. How does the human mind process these structures? And how do we learn them in the first place? For example, when babies learn language, we don't sit them down and tell them, these are the rules for how verbs and nouns combine. I mean, try doing that with a 1-year-old, and you'll see why. Instead, we learn language by observing the people around us use language. And from the time they're born, babies are super tuned to the patterns and regularities in the language they hear around them. In other words, a key part of how we learn language is through associations. And one way of studying how people learn through association is by investigating how people learn made-up languages in controlled laboratory kind of experiments. But these can't tell us how people learn through associations with real language data, and they also can't tell us about the limitations of what is possible to learn through associations. To do that, we need to study how structured associations work at scale. And in my lab, that's exactly where AI models come in. So here's the recipe. First, we take an artificial deep neural network model, and we train it on a large data set of natural text, like books or news articles on the internet. And these models are really good at learning statistical patterns. So they see all the sentences in their training data, and they use that information to predict patterns in future sentences, kind of like autocomplete on your phone. Then we run experiments on these models to try to figure out what kind of structures they've learned. For example, if a model sees the word green during training and it sees the word walrus during training, but it never sees those two words together, we can test whether the model can learn to structurally combine those words in a meaningful way. And remember that the models are blank slates, so there's nothing inside of them that's explicitly enforcing that they need to be learning those kinds of structures. So whatever kinds of structures they do learn, they're learning purely through association. Now, what's exciting about this recipe is that whether models succeed or fail at learning the right structures, we as scientists can learn something new about how language might work in the human mind. In my own research, we've shown that AI models are surprisingly good at learning many kinds of complex structures in language and beyond. And this suggests that many of the structures that we think of as signatures of human intelligence can in fact be learned through association. But models also fail to learn structure in other important ways. And these failures can tell us about the limitations of what can be learned through association. For example, let's say you ask an AI model to generate an image of a green walrus sneezing the foam off a matcha latte. One thing a model might do is give you an image of a brown walrus with a green matcha latte. And why is that? The model's failure suggests that it's relying too heavily on associations and it hasn't learned the right structure. So remember that the model was trained on a data set from the internet. And on the internet, you see a lot of brown walruses and a lot of green matcha. So the model learns to associate the color brown with walrus and green with matcha. So when you ask the model for a green walrus, it doesn't know what to do. It just relies on the strongest associations that it's learned. But if the model had been able to learn the right structures from associations, the same kind of structures that you use to understand what a green walrus is, then the model would have no problem creating the image that you asked for. In this case, the model's failure can tell us about the limitations of depending only on associations to learn structure. And this also suggests that humans might have a bias for learning structure on top of the tendency to learn from associations. But AI models don't give us all the answers about how the human mind works. One major wrinkle is the sheer amount of data these models need to be trained on. So it's estimated that humans encounter about 100 million words by the time they're 10 years old. And by that time, they've mastered their native language. So sure, a 10-year-old might not be writing a novel, but a 10-year-old knows the structures of their language, and they can use it fluently and effortlessly. By contrast, a model like GPT-3, which was one of the first language models to really master human language, was trained on 200 billion tokens. In other words, GPT-3 got exposure to the equivalent of 20,000 human years of text data. Now, it's true that GPT-3 can do a lot of things a 10-year-old can't do, like write a professional email, for example. But think of the incredible power of a 10-year-old's mind. The infinity of sentences it can understand and produce, the worlds it can create, the fantastical places it can go that no human has ever gone before. And all of this is achieved with a tiny fraction of the data and the resources that it would take for an AI model to even begin to use language fluently. So even if AI models are surprisingly good at learning complicated structures through associations, humans seem to be getting more from less. So AI is giving us an unprecedented tool, an opportunity for studying what makes us uniquely human. And now that AI is embedded everywhere in our daily lives, I hope you don't just take it to be a magical oracle or black box. Instead, the next time you interact with AI, whether it's a chatbot or an assistant, try asking yourself, what about the model's behavior feels like human intelligence? How did the model learn these behaviors? And what can this learning process tell us about the model's biases and limitations? Keep asking these questions, and you might learn something new about your own mind along the way. Thank you.